Hello, I'm Julia Child. I'm in my own kitchen today and I'm boiling up some primordial soup. And there is a primordial soup machine. We're doing a recipe for the chemical building blocks of life. Today at the Smithsonian. National Air and Space Museum. I'm Julia Child, and today I have turned my kitchen into a biochemical laboratory to show you what some scientists think could have been nature's recipe for life on this earth, and perhaps life in the rest of the universe. Before life appeared on Earth, the atmosphere was probably water vapor, hydrogen, ammonia, and methane. And here is a fanciful reproduction of what things might have looked like. You've got the sea down there, and here's a volcano blowing its top. Here's lightning, thunder clouds, and the sun. And exactly the same thing happened then as happens now. The sun evaporated the water, which turned into vapor and came up into the atmosphere, circulated around, condensed, and fell down into the sea again. Something happened to that water vapor when it was up here in the atmosphere. It was smacked by the lightning, by volcanic gases and cosmic rays and who knows what else. In 1953, Professor Harold Urey had the bright idea of trying to reproduce all of this in the laboratory, and he suggested his idea to young Stanley Miller, his research assistant, only 23 years old at the time. And Miller came up with this concoction of bulbs and tubes. Now here's how Miller's machine works. This is water representing the ocean. And this tube up here leads to the atmosphere. And that was filled with hydrogen, ammonia, and methane, and electric sparks. And that is to reproduce lightning bolts. And then this tube leads down again and around to the water. And Miller heated the water, boiled it, and it vaporized, and the vapor went up through the tube here and into the atmosphere and was smacked by the electricity and condensed as though it were rain and fell right down into here and came back into this original water. And after about a week of this continual recirculation, a fantastic transformation took place. The very simple ingredients in Miller's contraption had turned into some very complicated chemical compounds, including 4 of the amino acids essential to life. Why had this happened? It was because he had added energy in the form of heat and electricity. But this was just the beginning. Since then, scientists believe that they have synthesized almost all the remaining chemical building blocks of life. And they did this by more nearly reconstructing what they believed was the ancient environment. Today, Dr. Cyril Ponampuruma and his students are experimenting with a machine like this, which does look rather like an early permanent wave machine. Urey and Miller, as you remember, used just water, but Ponampuruma uses water plus a number of other substances that he feels more nearly duplicate the ancient ocean. And scientists call this the primordial soup. And here is Dr. Ponampuruma's recipe for a typical primordial soup. I'm going to make it for you right now. Well, this recipe makes 1 liter, so you need 1 liter of pure distilled water. And a liter is just a little bit more than a quart, 4 1/3 cups to be exact. That's what it's in here. And then we have 24 grams of sodium chloride. That's plain old table salt. and 24 grams is just about a tablespoon and 3/4. And then we have 4 grams of sodium sulfate. 4 grams is a scant teaspoon. So there's a scant teaspoon. And then we have 1 gram of potassium bromide. And this is, it's really a pinch, and this is a scientific pinch machine. So there we have 1 pinch of potassium bromide and another pinch of potassium chloride. Another pinch. 9 grams of calcium chloride, and 9 grams is 1 teaspoon and a scant teaspoon. And then we have 20 grams of magnesium chloride, and 20 grams is 4 teaspoons, about 1, 2, 3, 4. Then take your wire whip. There, stir it all up, and that's all there is to your primordial soup. And that's what's here in the bottom sphere of Dr. Punamparuna's machine. This is the heating element, and it boils up the soup. I'm going to move this over so you can see. And it comes through this tube, which is insulated to keep the vapor warm, and it goes into the atmosphere, which is ammonia, hydrogen, and methane. There are electric sparks in here, which we'll see later. And then it comes down through this part, which is the cooling system. This has continually circulating cold water. And this condenses the vapor into rain, and it falls back down into the sea. Now I'm going to turn the machine on, and you're going to see how it works. There we go! Now here's the vapor that's being vaporized up here, goes through the tube, and it gets zapped by these electric sparks in the atmosphere, falls down and is condensed, and falls down and is recirculated again. Now I'm going to turn the machine off. But pretty soon, with this continual exchange from soupy sea to gaseous atmosphere and down to soupy sea again, always going through shocks of energy, we're going to be making almost all of the chemical components, the building blocks of life. And these include amino acids, carbohydrates, and some of the components of DNA and RNA. And DNA and RNA are the molecules that transmit the genetic code. And that means heredity from generation to generation in all living things. So this transformation always takes place when you add energy to the ingredients in this recipe. But just think what this means. Starting with water and perfectly ordinary chemicals and minerals like table salt, not only scientists, but anyone, you and I, can go into a chemical laboratory and we can make primordial soup and chemical building blocks. Of course, the next step is how to put these chemical building blocks together. Can we make life? And is this the way life began on this earth? Who knows? And is this same process taking place on other planets? We don't know yet, but according to the laws of probability, it certainly could be. So, that's all on the chemical building blocks of life in primordial soup. This is Julia Child. Bon appetit.